Welcome to the NVIDIA Omniverse live stream, everybody. We have a very special show today. As you can see, we have many special guests here. We're going to be covering some really exciting stuff, especially for all everyone there who's familiar with the term SDG or Isaac Sim or Replicator or USD. We're having it all today. We have a very special guest from Edge Impulse, Jenny Plunkett here. Hey, Jenny.
Hi.
As well as folks from the Omniverse team. Hello, Ashley.
Hello.
Keel.
Hey guys, how's it going?
And Rishabh, very grateful to have you all here. We're going to do a couple of quick announcements. So we'll start with that, and then we'll kick things into high gear right afterwards. There's some really amazing things happening that we want to make sure everybody knows about. Starting with the big one, which is, of course, GTC, which is in person from March 17th to 21 in California. We really hope everybody can come and make it this year. Everyone who's able to. We're going to do our best to support those who can't with some virtual stuff. But if you go to NVIDIA.com/GTC, you're going to find all the early registration stuff on there. It's great session information is coming out. The pages were just updated this week. If you're not sure what's happening there, here are some key topics. There's something in there literally for everybody. We are very excited to put this on. It's going to be our first in-person GTC in a few years, actually. So we are totally pumped to see all the users, developers out there in the community. We've got some great stuff planned, even outside of the sessions for some get-togethers. I would say check out the GTC page. And then if you have any questions, we have a GTC channel on the Omniverse Discord server, which is discord.gg/NVIDIA Omniverse. We'll actually be headed there after the stream today to take any questions that we didn't get to cover in the stream today with our panelists. But look at some of those people who were there. I recognize at least one of those people. Actually, I recognize a couple of those people. So a really all-star cast will be presenting the latest research and developments from NVIDIA and other companies. Akil, I know you'll be there, right?
I'll be there for sure.
Ashley,
Yes, I get to be there.
awesome. So it'll be a lot of fun. Jenny, do you know if you're going yet?
I am. I'm going.
Okay.
I'm excited. Yeah.
All right. So it all hinges on Rishabh. Are you going?
Yep, I will be.
Oh, all right. Come on. Full house.
Wow, all of us. It's a party.
Yeah.
So it will be exactly that. So really excited. If you're going there, let us know in the GTC channel. If you want to set up a private meeting, just hit me up on Discord or on email, NVIDIA@NVIDIA.com. We'll set something up. We'll be honored to meet you all. Look what just came out. What great timing. A new Replicator release is available. Boosts the creation of synthetic data for computer vision applications with new low-code workflows. We're going to be covering some of that stuff today. We had a great blog just announcing this. Amelia, who's our superstar in the background, we're posting these links during the live stream. If you missed something else, missed a link, just post it in the comments. We'll get it over there for you. But we are going to be diving into some of this stuff today. We talked about this recently also. Marmoset has new support for USD. So open up your latest Marmoset tool bag. We're hoping to have these folks on a live stream soon. We covered with some creators also just a couple weeks ago. So we'll post that link for that live stream in the chat. But really help empower your 3D workflows with USD. And in collaboration with the NVIDIA Studio team, we have this amazing challenge happening right now, the Seasonal Art Challenge, which Ashley jumped in on right away with her Nana's house. And I remember the skull that was there, which we were debating whether it was her Nana, but we'll see.
I'll replace my background so you can see it.
What she does, there you go. There it is.
Sweet.
So that is a great opportunity for you to show off your workflows that have to do with anything with Halloween or this October related. November is actually just a few days away. So if you want to shift and show Thanksgiving related stuff or anything that makes you think of that time of the year, we would love to show your work. So post it on social media with the Seasonal Art Challenge hashtag. If you're curious what other people have posted, just search for the hashtag. You're going to see some amazing stuff. Really cool stuff I'm posted there nearly every day. The latest video on USD, this USD series from Aaron Luck, just released a couple weeks ago on custom schemas. This, I believe, is the 4th video in the series. It's amazing. So if you are just diving into USD or you're a USD veteran, Aaron goes into stuff that everyone can take away great nuggets from. If you have any questions on this series, please come on in the Omniverse Discord server and we'll help you out. We'll post a link for this in the chat, but definitely a fantastic resource. Ashley's been working on this next one actually a lot. Validate your OpenUSD for free. As you mentioned on a live stream a few weeks ago, RunUSD is not a new wrap band. It's actually a free validation service from NVIDIA to ensure USD compatibility for all your applications. Ashley, you have been doing actually a lot of work with. You're actually working on a cool video, I think, right?
Yeah. I want to show off how cool it is to use RunUSD to find, like, when you find assets that you want to use in your scene. Maybe you got it from like a team member, or you got it from somewhere like CG Trader or Sketchfab. You want to make sure that that asset is compatible with your main scene before you do all the work to bring it in. So using RunUSD is really important for checking that workflow. And then it can actually give you like a detailed description on if something fails and why it failed, and bring that into Omniverse to use our asset validator tool to fix the issue very easily. So I'm going to make a whole video on that so we can all learn it very quickly and very easily, because it is cool and I use it a lot.
Okay, so we're going to definitely dive into that. I think it's a great resource. I saw a sneak peek of that video earlier. It's awesome. So great job, Ashley, as always. And then the last thing we'll go into before we kick things off is the computer vision series is in progress right now. There are 3 different events. The first one is actually today. So we're going to post a link in the chat. It's a free series. You can join in at any of the sessions for. I'll post a little quick video of session 2 and session 3, so you guys can see what it's all about. And I thought there was audio on this one, so maybe not. So I'll just whistle on. Okay, there. So that session
How we
is,
were the background for it.
I know. I was afraid to change the screen because last time we flew on a StreamYard and it went bazonkers. So anyway, that session you just saw is on November 1st. We're going to post a link in the chat. But again, check out the webpage and sign up for a totally free computer vision series, which this is very much related to our topic of today, of course. So speaking of which, so let's go around before we dive into things. Let's go around and do a quick introduction so everybody kind of gets a feel for who's here and how to post your questions in the chat. We'll go in the order of the screen. So Ashley, my friend, why don't you tell everybody about what you do here at NVIDIA?
I'm going to get really good at this elevator pitch of myself, by the way, if I just keep coming on the stream. So hi, I'm Ashley Goldstein. I'm a developer advocate for Omniverse Exchange. You'll see me a lot on these live streams. My own live stream, which is Monday and Wednesdays, it's called the Learn With Me series. It's at 1 o'clock Eastern time, 10 a.m. Pacific time. And my role at NVIDIA is to help developers of all sorts, coders and non-coders, creators of anything, to get familiar with the Omniverse platform and create really cool tools. So I do a lot of workshops, I create samples and videos, and you'll see me at conferences like SIGGRAPH and GTC teaching DLI courses.
And she's super active on Discord, so you'll probably notice that her presence there in full force. So thanks for joining us, Ashley. And next to you is Jenny Plunkett from Edge Impulse. Hey, Jenny.
Hey, thanks for having me. This is such a blast. Actually, my role at Edge Impulse is very similar to Ashley's at NVIDIA. I am a senior developer relations engineer at Edge Impulse, and I've been here for 3 years now. And recently I was working very closely with the Omniverse team on creating an extension to integrate Edge Impulse into the Omniverse environment and hosting that extension on the Omniverse Exchange. And last year I wrote a book, AI at the Edge, which is about how we can implement real world machine learning use cases for Edge products. And I wrote that with my colleague, Dan Sitanaika, and we published that in January. And I do workshops and talks, and I support the Edge Impulse developer community with machine learning models and Edge training. And this year I've been really working a lot with the NVIDIA Omniverse stuff and Tau as well.
Well, it is extreme pleasure to have you here. Thank you so much. We're excited for your presentation in a few minutes. Akil, tell us a bit about your role here at NVIDIA.
Yeah, thanks, Edmar. So yeah, I work in product marketing for NVIDIA Omniverse, primarily focused on synthetic data. And this is my first live stream. And so my son told me that I better do a good job. So he's a big artist, and so he follows all sorts of artists on live stream. And I told him I'm doing one today. He's like, "Oh yeah, that's cool. Don't mess it up." So I've got a lot of pressure, even though it's not a pressure situation. I've got pressure for my son, so I'm gonna try my best to make it so that he's happy with everything. But really happy to be here and support this.
I'm very happy to have you here. So for those watching, he's very modest. Akil is a very big part of this team here, so it's an honor also to have him here. He's going to help give us an overview of things in a few minutes and kind of put things in perspective and how things connect to each other. So really happy to have you here. And last but not least, how are you doing, my friend?
Hi, Edma. Thanks. I'm Rishabh. I'm a tech marketing engineer with the Jetson team, and I primarily focus on robotic simulation. So I've got experience in terms of simulating stuff with Isaac Sim and simulators and doing cool things there, training models there from using synthetic data, using assets, and that's something which we will be getting into in our live stream today. Training that model, then optimizing it, deploying it on a robot in the real world, and making it do cool stuff. I think that sounds very, very interesting to me, and I'm looking forward to making sure everyone can understand what those workflows look like and try it out themselves. I've also done a live stream in the past for Isaac Sim with the ROS workflow, so got experience with the ROS side there too. And we've got questions around Isaac Sim. I hope I can answer them.
Thank you so much. I'm really glad you're here. He's a veteran now with the live streams, and we're able to sneak in something on this live stream because of the great timing of this. Isaac Sim just had a pretty significant update. So we're going to sneak in an overview of some of those features a little later. So if anyone's watching here, a big Isaac fan, you've come to the right place. But speaking of Isaac, so this stream is training computer vision models with synthetic data. And there's kind of a few different kind of topics that are kind of mixed here. So obviously OpenUSD is all part of it, but then we've got Replicator, we've got Isaac Sim, and obviously Edge Impulse is here to talk about their work. To help us put that all in perspective, Akil, could you kind of run through things with us? And I think Amelia had posted the blog that was just posted today in the chat.
Yeah, let me share my screen, and I think I'm watching the chat, and somebody just asked, "What does the term synthetic data mean?" So I think it's perfect timing for that question. I've got a few slides, and I think it will help for people to understand what we're trying to do and what synthetic data really means. So let me go into presenter mode, and Edmar, just confirm for me if you can see.
Yeah, we can see it. Looks great.
Okay. All right. So this is just an overview of Replicator, but I'll type, what Edmar said with respect to OpenUSD and also Isaac Sim along the way. So you'll see the story sort of build as I talk through the examples. He did a great plug for showing off that computer vision video where you saw that gentleman, take things from one part of the conveyor, put it on the other side, and we're tracking the boxes and if that person's wearing a safety hat or not. That's a great example of computer vision, but there's so many more different examples that we can talk about. Think about traffic management. We see cities applying intelligent license plate detection. So how do you do that in a crowded city environment? What about manufacturing, where you have to find defects in pretty much any part that's manufactured? And this is a huge area where computer vision is applied. Think about retail. If you've been to one of those Amazon Go stores, you just walk in, you grab the stuff you need, and you walk out and you automatically get billed. That's a great computer vision example. Healthcare, you think about smart hospitals for patient care, but also robotic assisted surgeries, autonomous vehicles. We hear about it every day. Some good, some not so good in terms of what happened to Cruise. But the whole point is computer vision is powering all these different types of applications that's out there. Now, when you step back and think about what's really powering that computer vision application, it's an AI model. And so the AI model that is built has to be trained on a lot of data, and it's fine-tuned and it's optimized for that specific use case. So if you see this workflow that I've built, it's very simplistic, and I just want to kind of give an example of what that workflow looks like from left to right. So it starts with data preparation. Here's where you go wrangle your data. You grab a bunch of images, you grab a lot of video footage, if you will, look at public domains, and you bring that data in and you start labeling that data for your use case. Then you have to select a model. A model is essentially a pre-trained neural network model, something that can detect objects or something that can segment things if you want. And you fine-tune that with your data, and then you optimize it. And Jenny will walk through sort of like the edge pieces of it, but the optimization is really to make sure that a model can run effectively on a device that's running on the edge. Let's say let's say at a factory, or maybe at a quick service restaurant. You take the model, you integrate it into an app, you deploy it, you monitor it, and that cycle continues over and over and over again. So it's a very simplistic, high-level view. Obviously, there's so many more different steps to it. Now, if you think about just the data part, I'll start with the first one. And do you see a typo there? I see a typo there, but apologize for that. But it's difficult to collect. And the idea is that if you have an example here where you have a printed circuit board and this component is rotated, this is an anomaly detection. This doesn't happen a lot in real life. So now you have to sit there and wait for another PCB to come around so you can catch that defect. So how do you sort of get a lot of data where you can then train a model effectively? Think about all the edge use cases that you may run into. Maybe a robot has to go around the factory but not collide into things. That's an edge use case, because how do you make a robot run into things and then collect the data? So you have to do it very safely, and that becomes a challenge for many developers that we see day in and day out. The second one is, let's say you're tasked with building an application for public safety, a crowded stadium, and you want to be able to design the proper exits or whatever it might be. Well, people are going to be in and out of that. And so how do you train a model where you just simply can't take pictures of people without their consent? So privacy becomes a big issue. A flip side of that is also diversity. If you're building a facial recognition application, you need different types of people, different races, different gender. Everything has to work out. And again, that's the diversity aspect of it. So again, without encroaching the privacy of humans, how do you sort of collect data and train a model? The third one that we're seeing is, data can span beyond just the color spectrum. And again, this is where you start to get into LiDAR and radar type applications where, for the naked eye, I can see that this is a shelf, these are boxes, but how do you label and annotate it? And how do you do that for a time-based scenario where if the vehicle is moving, it's collecting data at t equals 1, 5, 10 minutes, whatever it might be. How do you collect that data over time? So that becomes a challenge as well. And finally, things are constantly changing, right? For example, in this retail shelf example, the cereal box may not be there tomorrow when you go there because some other retailer paid more money to get that shelf space. So when things are in constant motion, the data that you collected yesterday is already obsolete. And so how do you retrain a model quickly? And that's again a data challenge, because now you have to send somebody out there to take pictures and retrain the model. So we see a lot of issues in talking to our developer community about how do we help them overcome these data challenges. And that's really where synthetic data comes into play. So if you think about synthetic data, it's really data generated from 3D simulations or algorithms. So all of you who are on this call and are familiar with building 3D models or 3D simulation models, this is really an output of that. And so if you see the middle picture here, it's just all the boxes that you see drawn around the crates, they're essentially coming from a 3D model that was built. So we can leverage an existing 3D model and generate 2D images from it to train a computer simulation model. And what's great about that is that you may not have the data for this specific use case, and so synthetic data can help you bootstrap that while you collect real data to get your model training going. So again, synthetic data is generated from 3D simulations, and you can mix and match that with real data. But what's great about that is that you can bootstrap or get started while you're collecting real data. So then you might be thinking, well, what's NVIDIA's role? What's our position in this entire universe? And so NVIDIA Omniverse is a developer platform for 3D workflows. Replicator is a core extension of that. And so it allows you, the developer, to build your own custom synthetic data generation pipeline. And Jenny will talk about that from a developer perspective, so will Rishabh. But the idea is that we're going to give you the tools and the APIs so that you can build your own custom app or extension that allows you to generate data to train an AI model. So one example is, let me connect the dots with respect to Replicator and Isaac Sim. Isaac Sim is a robotics simulation platform. And a core part of that is using synthetic data. So it uses the APIs from Replicator in Isaac Sim so that if you're a roboticist, then you can use the routines in Isaac Sim to then generate data. So essentially, it's extensible because it's built on USD. It's composable. And so you can customize it to your own use case. Great example, again, is if you're in the manufacturing field and you wanted to build a computer vision application to detect defects, you would then use Replicator, build your own custom app or extension for that defect detection use case, and then generate data to then train an AI model. So we are going to give you all the developer tools to build on top of it. Isaac Sim leverages our APIs for robotics. You could have another custom application that leverages Replicator for a specific workflow. So we're pretty extensible, super agnostic to any sort of use case that you want. And again, our goal is really the fact that we're built on open standards like OpenUSD, so we can extend beyond what the tools that we're giving you. And to me, the biggest thing, the biggest exciting thing is the fact that we can allow you to bootstrap your model. I talked to a lot of customers, and the biggest issue that they have is, I don't have enough data. I don't have enough data to account for all the different use cases. What can we do here? And that's really where synthetic data can really come in and help you out. So how does it look when you start to think about introducing synthetic data to the model training workflow, right? So it changes a little. You saw my initial workflow where I had the data to training to deployment. All that remains the same, but now we're leveraging existing data from 3D CAD models or 3D DCC tools. We're going to bring that data and we're going to build a scene. A scene could be a warehouse with all the shelves, the boxes in it. We can have the robots. We can have people in there. So essentially a scene that you build. And once you have that, you start to do what we call domain randomization. This is the key part of Replicator. And Rishabh's going to talk about that, where you can change the lighting, you can change the location of the objects, you can change the color, the texture, you can bring in different types of sensors, and really get a rich and diverse data set that allows you to then go and train the model. And once you train the model, you get the results back and you go, okay, you know what, this is not working for me. I got to go try a couple more things. So now if you think about real data, you can go back and find more real data. But if you use Replicator or synthetic data, you can quickly tweak the parameters that you think will make an impact to the model, and then speed up that iteration cycle while you bring real data in to finally validate your model. So the future, essentially the happy place for this is a great combination of synthetic data to real data. And so as you think about your workflow, it really starts with what you already know as a developer. I know how to build 3D scenes. I know how to randomize stuff. Let me go take that one step further to train the model. And so with that, I'm going to stop my PowerPoint. I'm going to share a couple of things here. Edmar talked about, obviously, the latest version of Replicator is out, so pretty exciting stuff there. And the biggest thing that I want to point out is that we are trying to make it really easy for non-3D experts to jump in and generate synthetic data. And one of the things that we've done is to build what we call a YAML workflow. So for those of you who are aware of YAML, it's basically text-based descriptive file. So you say light, you say randomize, you give the parameters, and then the YAML file will talk to the core APIs within Replicator, and you don't have to learn about the coding within Replicator at that point. So we're trying to really abstract away the need for you to learn the core coding technology and really interact it from a YAML perspective, which I think in the long run will make it super easy for pretty much anybody to jump on and start generating data. The second thing that I want to bring up is, and this is maybe more for the advanced users, is asynchronous rendering. So today, if you wanted to generate data, you have to simulate something. So let's take a robot. It has to go 5 feet, stop, render the images, and then do the same thing again. So now we're offloading the simulation bit and the rendering bit, which means that things will get a lot faster. So you can run your simulation as in the robot can continuously traverse the floor space, and then it's going to offload the rendering. That way, the simulation can run independently of the rendering. So we're trying to speed that process up. And finally, the event-based triggers, as we call it, or conditional triggers. As you can see in this little animation here, as the robot moves to the next bit, you can say now drop the objects or move that crate out to the next level. So you can create your own custom triggers. Another great example is if there's a robotic arm sitting there, it's going to grab a box. You don't want that robot arm to move until the box gets close to it. So that allows you to create or have a little bit more flexibility into how you generate the data. So really 3 awesome key features, I would say, but there's so many other smaller ones that are part of that. So definitely go check it out, play around with Replicator. I'd love to hear what the kind of use cases all of you are looking at. And I know that Ashley also dropped in videos on the series that we just created. So in April, we launched this defect detection use case, and we had a really cool video, but we didn't have a great chance to show you how the entire extension actually works. So if you're looking at building defect detection type use cases, we have now 4 videos that start off with showing you the extension, then how do you work with the extension, and finally, if you're serious about modifying it, you can go in the back end and modify the extension to your liking. So pretty cool video series. And then we have a blog that's there. Rishabh essentially wrote a blog that he's going to talk about for his use case. But what we're trying to do is essentially make it so that developers like yourself can just grab Replicator and build your own extension, your own custom app, and generate data to train your AI models. So that's my quick overview. Hopefully it's clear now as to what synthetic data is and how you can use it and what Replicator is. And again, Isaac Sim leverages the core APIs for Replicator, but if you're doing just simple defect detection, you can still use Replicator to build your own custom workflow on top. So with that, Edmar, I'm going to pass it back to you. I'm going to stop sharing.
That's great. And I'm glad you mentioned Ashley's playlist there. So I just posted that playlist in the chat. If anyone misses any links, feel free to, it's so great to see all the lively chat happening right now. So great to see everybody here. I think we're going to hand it over to Jenny now to talk about how Edge Impulse, or should I say Yenster? I don't know.
Yeah,
Is it you?
That is me. But don't tell anybody. That's my. No, I'm just kidding.
Cat's out of the bag now.
Yeah,
I saw it and I was like, wow, another woman. There's so many women in the chat and stuff. And then I was like, wait, where's Jenny?
No, that's just me. I didn't have time to log into my professional YouTube account. So, but anyways, there's nothing on that one. Don't worry. But anyways, yeah. So I'm happy to talk about Edge Impulse now. There's so much exciting things that Akil brought up in this new release, which I haven't gotten to use yet. But considering how easy Replicator was to use, it's like to make it even easier and to do it asynchronously. It's like I'm really excited to dig in. But since I'm not sure who is familiar with Edge Impulse, I thought I'd just do like a little spiel, and whatever questions, just
That'd
feel
be
free
great.
to ask. Just ask it in the chat, and I'm happy to do this a bit informally. But Edge Impulse is essentially an online platform that is completely end-to-end that allows you to collect your data, label your data set, design and train your machine learning model, and deploy to any edge device or locally on your computer with a bunch of different libraries that we support, including from really small, ultra low power microcontrollers all the way up to Linux CPU targets or NVIDIA GPUs, for example. So it's a completely free tool. If you're a developer, you can sign up today. Just go to studio.edgeimpulse.com and you can get started. And I'll go through and basically do the same sort of show what I did for this use case that I did with this blog with Omniverse a few weeks ago. And it's how to train an object detection model for visual inspection with synthetic data. And this was all done via Omniverse Replicator, the previous version at least, and Edge Impulse. And it can all be done with the free tools shown in the blog. But yeah, so that's essentially Edge Impulse. Again, feel free to ask any questions in the chat. But it's a super easy way to get from data all the way to deployed model for any Edge product. And specifically in an enterprise grade fashion. So yeah, let me switch to Omniverse and then I'll show a little bit what I did with Replicator.
Very cool. As Jenny mentioned, Jeff, feel free to put your comments and questions in the chat. We also plan to head over to Discord afterwards to go to the community room 1. So if you're not a member of Discord, go ahead and join now so that you can chat with us. Discord.gg/NVIDIA Omniverse. And I think I have Yenster's screen here. There we go.
Oh God. Okay. That's so funny hearing you call me Yenster. Sorry. It cracks me up a little bit. Anyways. So this is the environment that I ended up creating in Omniverse. And specifically the use case that we at Edge Impulse and the Omniverse team wanted to show off for our first blog post in collaboration was was something industrial related. So what we thought of immediately on Edge Impulse's side was, what is something that a customer of ours would actually want to see? And that's doing sort of computer vision tasks with industrial products or industrial manufacturing lines. So what I did is I basically used Omniverse to generate a conveyor belt. And these are all handy. They're all already in Omniverse. I didn't have to find any asset for the conveyor belt, which was awesome. And then I took a USD file for a can. And because it was a Pepsi can, I had to remove the label and make my own label for it so we don't get into any legal issues. So you can see here I've made,
the Edge.
I've made an Edge Impulse soda. Edge, zero sugar soda.
I love it.
And so the replicator script, it was so shockingly easy to write the replicator Python. And I wouldn't consider myself like an amazing programmer, but to be able to just like have such easy classes and manipulate all the objects in the 3D space was just like it was such an awesome thing. It really fired me up to do and to write this blog and write these tutorials. But yeah, so essentially what I did is I generated multiple cans on the conveyor belt, and I just defined the space. There's a few rectangles on here that allow me to basically procedurally randomize the location of these cans on the conveyor belt. And then I set up a couple cameras from different angles, and the replicator script will go through and change the positions of the cans randomly based on those rectangular regions that I defined on the conveyor belt. And it will also rotate the cans. So I'm using the scatter 2D function for that. Which was really cool because it also allows you to check for collisions. So the cans aren't overlapping each other in a way that's not physically possible in the real world. So this was like a great first use case that I thought we could do at Edge Impulse. But basically the cameras then generated some data sets, and the data sets I then uploaded to Edge Impulse, which is where we did our automated data set labeling. And the whole goal of the machine learning model that I wanted to create from this synthetically generated data set was to eventually do some sort of visual anomaly detection. So we're doing a lot of advancements with visual anomaly detection at Edge Impulse, some of which are not yet publicly available, but internally we have them going on. Unfortunately, I don't have the demo set up for that today, but one of the things that we're looking at doing is, how can we even make synthetic data set generation and eventual model deployment to a real edge device even easier? And one of those things is like taking a data set full of nominal images of fully functioning, non-broken, non-scratched up cans, and training an entire nominal machine learning model, and then deploying that to the edge, and then using another algorithm that will, based off of the nominal data set, identify when there are defects without having to create a whole new data set full of defect images to train the initial model on. Of course, as you deploy your model to production devices, you're going to want to increase the accuracy of your model, which is where things like, I think maybe that's also talked about in the blog, Akil, but with the generative AI stuff with Omniverse Replicator, I'm so excited to use that because it's basically just going to be a game changer of being able to add scratches and other defects to the cans, and completely changed my test data set for my nominal only model, for example, before I even deploy into a factory. So that's the Omniverse side of things. You can also see on the bottom right here, I do have a small little data ingestion extension, which I just quickly wrote with the Edge Impulse API, REST API. And this is the extension that is hosted on the Omniverse Exchange. We will be extending the extensions for Edge Impulse and Omniverse even more over the next coming months before GTC. So keep an eye out on the Edge Impulse blog and the Omniverse blog for that. But then really quickly, I wanted to show what we actually did. What does like the Edge Impulse Studio look like? So I'm going to share that. Okay.
Okay, I think we see it now.
Great. So this is Edge Impulse. This is freely accessible. I think I even have this project public, so I'll just post that So that can be put in the chat right now. But yeah, so this is the Edge Impulse project that I created from the synthetically generated data set from Omniverse. And basically, I just took, it's really not a big data set, as you can see. The data acquisition tab is where I can see my training data set and my testing data set. And I just have all my cans labeled here with bounding boxes that I labeled from the labeling queue option that we have in Edge Impulse. I could upload another picture right now from my computer so I can see show you what that looks like. Rendered.
Very cool. Lots of great comments and questions in the chat. While you're looking for that, we had a question from Data Juggler asking how you did the label on your awesome new beverage, Edge.
Oh, so yeah, the Edge label, I just took, so I basically, USD asset files are so cool because it's like, they're basically layers of various 3D effects and shading and stuff. And basically the Pepsi Max logo was just a JPEG file. So I took that Pepsi Max logo, the JPEG file, opened it up in Photoshop, and I just like replaced the Pepsi stuff. And it was so easy. It was awesome. I was like, this is amazing. It took me literally like 10 minutes. And so I was going to do that with a bunch of other different types of cans too. But then I was like, in reality, you're not going to have on a conveyor belt line in a real factory like this, you're not going to have different types of soda on the same factory line. So I was like, that's not really applicable for this use case, but
very cool though. Thanks for explaining.
Yeah. So this was the labeling queue. Of course, I only had like 100 data items here. So I didn't really take that much data from Omniverse. You can get a really solid model depending on your use case with just small amounts of data. But I opened it up in the labeling queue, and there's a few different options that you can do in here. In Edge Impulse, we do have auto labeling options where you can classify the objects in your image that's unlabeled with YOLO v5. You can also classify the objects and put the bounding boxes on the objects and images with a model that you've already trained previously. So you can basically use active learning in order to improve your model and also improve your auto labeling processes over time. But most of the time, I'll just sit here and sort of tune my brain off and draw the boxes. But if you're doing this for like a data set of like thousands of images, obviously that's not going to be very feasible. So I just click Save Labels, and that goes into my test data set.
Jenny, can I add something? I think it's cool that you have this feature, but within Replicator, all the data that's the images that are generated, you can get bounding boxes and labeling and segmentation out of that. So, if you want to do additional labeling and maybe some of the images were not labeled, then you could do that separately. But for the most part, like, we are building tools so that you can just grab those images and start training.
I did notice that as well. And I guess there was just a matter of like, for me, the quickest thing that I'm more familiar with is the tools in Edge Impulse. But I did notice that you can generate the bounding box labels files for every image that you take from Replicator, and it gets outputted into the folder wherever you save your Replicator images. I did notice that. I guess in this case I didn't use it, but because there was just such a small data set. But of course, in reality, you're going to want to use if you have like 1,000 images, for example, or plus, you're going to want to use the labeling files that are generated from Replicator for sure to reduce the workload. So I uploaded my training data set and my testing data set. And looks like I changed the capitalization there, so it looks like it's a different class. My bad.
By the way, we got some nice compliments on your UI. Very nice and clean interface.
Oh, thank you so much. I'll definitely relay that to the studio team. They've been working really hard. So it's just Edge Impulse is a very simple workflow. It literally just goes from top to bottom. And it's basically a graphical interface for what your machine learning pipeline would be. You have your raw data set, your digital signal processing to extract the most important features from your images. Then you're going to use those signal processing features in your machine learning algorithm, which we have a bunch of machine learning algorithms freely available for you to use. We're also integrating with NVIDIA Tau Toolkit, so you can bring in more pre-trained models into Edge Impulse and use with your synthetic data set. So it's like it's getting all very meta now, but we're very deeply involved with NVIDIA, and we also have another webinar with y'all on November 9th. So if you're interested in that, check us out. But yeah, so it just goes. We're a very low code platform, but we're not. Like we're completely enterprise tool. So everything that you see here, there's no black boxes. You have access to the code. You have access to all the intermediary files at every single step. And I won't go too deeply into Edge Impulse because we have a bunch of documentation on this already. But yeah, you can either do it this way, which is what I'm doing right now, with just clicking a few buttons, or you can do this completely programmatically. We also have a Python SDK, so you can train your model, extract your features, all of that via our Python SDK with our REST APIs. So nothing here is a black box. You don't even have to go into your web browser if you don't want to. If you just want to stay in Omniverse Replicator and use the Python SDK from Edge Impulse, you can run one big script that does everything you want. So, but yeah, I just wanted to show off a little bit of the model testing tab. You can also choose, all the different models that we officially support. This is where the Tau models will go as well. And yeah, we have just a great model testing page where you can see exactly your cans being labeled from your testing data set, from your synthetically generated data set in just a few minutes. So yeah.
Very cool.
I think I covered the majority of Edge Impulse, but I'll go to deployment after this. But if there's any questions,
no, well, mostly a lot of compliments. Basically, how simple and intuitive everything looks. As Science has posted, really nice how low code it is. So I think people are going to really be excited to dive into it. And it seems like you're leveraging a lot of cool technology in addition to your own. So really, really cool.
It's great to hear. We always want to make sure Edge Impulse is really approachable. I think Replicator is also really approachable. There was one question. They said for someone new to Replicator, Edge Impulse sounds cool. Where should we start learning? And I think it's just a matter of do you already have a use case in mind? Do you already have a data set? Do you already have a real world setting that you want to replicate in Replicator? I think maybe the Replicator team. Yeah, what is it?
Okay, so my use case, I posted this in the chat and David answered a lot of it, but I want to build a robot. Okay, so first off, preface, I have 4 dogs. So I need to keep them busy while I'm working. I want to make a robot that detects one of my dogs, and when it detects one of my dogs, it dispenses a treat. That's my use case.
That sounds incredibly powerful. I could see millions of people wanting to leverage that same robot. It's to me, it sounds very possible, but let's ask the experts. We got Rishab's here from the Isaac.
I can answer that question.
Yeah,
it is certainly doable. Yeah, given that, I think you'll find many. So I'm not sure we have dog assets with Replicator. Maybe Akhil can answer that part of the question for me. But if we do have access to pre-trained models from Tau, so if you've got a small data set with images of your dog already annotated with you could use a classification or a detection model in that case. I think that's something which someone in the comments pointed out too. So you can either classify or detect your dog, and for the robot part, we can simulate it too. So we can have a simple mobile robot with maybe a little place where you can store the treats, and we just actuate it in the sense that we release the treats once the mobile robot recognizes your dog. So we can train it with Tau, we can train it with other different frameworks of your choice, identify your dog, sees it. Maybe you can even have an audio something pop up saying that, oh, dog's here. So something which you pre-record. So that is something you could drop into. Yeah, and you should be able to drop
that
it
all day.
Yeah, then you would need another robot to monitor if you're not feeding the dog too many treats. That could get hairy.
I mean, this sounds like an incredible GTC session to me. And I think if I recall, Jensen is a big fan of dogs also, so maybe it's be part of the keynote. This sounds great.
We'll just have it on stage.
Yep.
Just run around dropping treats when it recognizes people instead.
This sounds
Ooh,
great. All right,
person.
and actually, so this is a great segue actually to. So thank you, Jenny. That was awesome.
Yeah, of
Very,
course.
very cool. And I think Jenny's coming afterwards to the Discord server to chat. So if you have any questions, if we don't get you in live stream, come hang out with us afterwards. It'll be a lot of fun. You can unmute your mic and show your cam if you want. Before we get to our next star of the show, Rishabh, we're going to play a quick video. I think an oldie but goodie. Talking about Isaac. Let me see if I have it here. I think I do. Here we go. All right. I also think that maybe NVIDIA should start a club because I'm hearing lots of cool club music. I know we were talking earlier in the warm up about our countdown clock music, and we had that music from that video, and I think we got a good night started. All right, cool. So Rishabh, I'm very happy to have you here once again on live stream. You're a veteran, and happy to hear. We have Isaac is obviously like one of the most popular topics also. So we'll dive into the Isaac features later. But yeah, so what are you going to share with us today?
Yep. I'll mostly be talking about the whole synthetic data generation and training workflow for AMR use case. So particularly around autonomous mobile robots in warehouse settings, where you would expect that your robots can better understand the environment which they're in. So it's more of a semantic understanding for the robots, and that can be done through images. So like a camera mounted on top of the robot, you'll be able to identify, detect objects around it, and hopefully that can be further fed into your downstream navigation stack, for example. So in case you want to identify on your warehouse map where certain objects are, that could be useful. Or depending on your use case, there are many ways to look at it. But I'll get started in terms of going through a blog quickly in terms of what we did, and then I'll get into the live part where we'll see Isaac Sim in action, and I'll be opening up a warehouse scene, dragging in robots in there, moving around assets, and show you how to do the SDG. And yeah, I think I'll start presenting my screen. It all sounds interesting, hopefully.
It sounds amazing. More than interesting. Feel free
I
to
didn't
share your
realize
screen.
you were at headquarters either. I thought you had one of those backgrounds, but
No.
you are actually in office.
Yep,
Look
I
at
am in
you.
office. I hope you can see my screen. Okay.
Yeah.
So let me first open up the blog, which I talked about earlier. So this is a blog which just went live, and I've worked with Akhil closely on this one. It was mainly centered around how do you get AMRs to better understand objects in the warehouse around it. So the premise being that we have limited access to real world data. And obviously, even if you do get access to real world data, somehow you need to go through the painful process of doing the annotations. And for simpler models, like we just saw, like for maybe classification and detection, annotation is relatively simpler because for classification, it's maybe you can just put all the similar images in a common folder, and that sort of solves your problem. But for detection, you need to figure out bounding boxes. But as soon as you start to go up that chain and you look at more complex models, maybe like segmentation, pose estimation, so for those, the annotation tools do exist, but the annotation does get a lot complex. So for example, imagine for segmentation, I would need to go around and try to draw a mask around this very pallet jack. So I need to go pixel by pixel, move my cursor around and make sure I'm capturing the pallet jack accurately, and then actually saving that annotation. And doing this for thousands of images, man, that seems to be like a lot of work. So that is where you can actually leverage the power of replicator and synthetic data. The advantage being that in your simulated scene, all the positions of the objects and the various attributes and features are already known to the simulation engine. So why can't you just get the data out there directly and then use it to train your model? So coming back to our pallet jack detection use case, we wanted to identify pallet jacks in warehouse settings. And we hoped that if we can get a lot of synthetic data and we can train our model on it, the model will also do well in the real world. So we went through a couple of iterations there. The first iteration being that we just added the pallet jacks into the scene as is, and we randomized their color, pose, along with randomizations in the camera. And now let me open up Isaac Sim so I can tell you what that means. So let's go ahead. This is Isaac Sim 2022.2.1. This was the previous release which we had. The newer release, which is 23, which just came out last week, is something which I'll dive into deeper. So I'll get to it at the end of our session. But let me create a simple environment right here. I'm going to create a small warehouse environment. It's going to be identical to the one which you're seeing in the blog right now. So this is a simple warehouse environment which comes in with Isaac Sim. It's already pre-baked with OV, so you don't need to worry about actually creating all the assets and then making sure things look right. We have this warehouse scene, and what we're going to do is we're going to add the relevant assets which we have for our use case. So I'm going to go assets, and I'm going to look at the digital twin sim-ready assets. So warehouse and equipment. I can go under equipment and I can find pallet trucks. So we have 3 sample pallet trucks available with our sim-ready asset library already. And I'm going to drag and drop a couple of them. I'll probably have to adjust the scale of them because the scale is off. So I'll make sure I have the scale correctly set. And yeah, sorry for the weird looking assets while I'm adjusting the scale. But yeah, here it is. Here's the right asset. So this is one sample pallet jack which we have right here. And we can also look at the other ones which are available. And it's the same thing which we need to do here for making sure that the scale is set correctly. So these are sample pallet jacks which I can drag, and there are also many different sim-ready assets which we have specifically for warehouse use cases, which I would strongly recommend you to look at in case you're interested. We have forklift assets, we've got pallet trucks, we've got ramps, we've got ladders, and a variety of different useful USD assets which you can leverage directly into your scenes.
Hey,
So,
Rishabh, I got a question for you.
Sure.
You brought a new term in called sim ready. Do you mind talking about what that means?
Yeah. No worries. Thanks, Akhil. Thanks for raising that. Yeah. So sim-ready assets basically is a bunch of collection of like a library of assets which we are providing directly for developers to leverage in their own simulations. And what it allows you to do, for example, in our case, which we're looking at the pallet jack right now. Let me select this pallet jack right here. If you closely see that all the textures, materials, and all the other meshes are correctly set for the assets, so you don't need to worry about anything. And I can also make sure that I can select this asset and assign it a class. So because this is the asset of interest for my use case, this is how I'm going to assign a class to it. And I can then generate data with a replicator to get my annotations out. So sim-ready assets is basically a collection of photorealistic assets, and you can just add physics to it by selecting the asset and selecting the appropriate physics approximation you want, like convex decomposition or convex hull. But it's basically, in one line, it's drag and drop assets into your own scene, and it's a big bunch of them. So it is going to be useful in case you're looking at warehouse robotics or other cases. So I hope that answered your question, Akhil.
Yeah, it does. And I think just to add to that, it's an effort essentially to make sure that when assets are created, they're created in many different tools. SimReady essentially carries forward the intelligence needed so that we can put this pallet jack in a simulation environment. Maybe we're not doing any AI with it, but maybe we're just going to drop it 5 feet just to see how it reacts, or use that pallet jack to then create data from it. And so having the metadata is really important. And each object should know what it is and what it needs to and how it needs to behave in a simulation environment. And that's really why SimReady is super important, not only for simulation, but also to help AI with AI training, especially when it comes to labeling. So just to add to what Rishabh said.
Yep. Thanks, Akhil. So yeah, getting back to you. So now we've got a sample scene set up with a few of the assets which we're interested in. And given that I'm targeting a robotics use case, I would want to maybe drag in a robot. So let me go ahead and do that. I'll go ahead and find the Isaac folder. Where's it? Right here. Look at the 2022, and we can look at a Carter. We have a bunch of robots coming, by the way, and with the new 23 release, there are many more robots in terms of AMRs and manipulators. So I would strongly recommend, if you're interested in figuring out what we have, that I'll be walking through the release notes as well, but it's something which you should certainly check out. So let me drag a simple Carter robot into the scene. And so this is our robot right here. I'm going to rotate it by 180 degrees to make sure we're looking at the pallet jacks, because that's where the camera is, in case it wasn't clear. So this is our real sense camera right here, and the top one, this area. That's where our camera is, and we're going to be looking at the scene from that camera's perspective. So let's go and look at it from the camera. So this is what the robot looks like in terms of when it's in the environment and it's going to be moving around. So you can obviously move the robot around, and then the viewport would correspondingly change for how the robot looks at the environment. So this is the basic idea in terms of how you would get assets into the scene and drag your robot in it. But what we would want to do is, like, this is not the only data I would want to collect, right? This is just a static scene where it's just got like 2 assets and maybe a robot inside it. I want to make sure like my data set has got a lot of diversity, and that's where domain randomization actually comes into the picture. So what that allows me to do is now I can move my objects of interest around the scene. So it allows me to move these pallet jacks, change the colors, change the lighting of the scene. So what do I mean by that? So let me look for the light right here in our scene. So we've got like a bunch of lights in the scene. We've got some of them enabled, we've got some of them disabled. You can keep on enabling the lights, and I can keep collecting data once I'm making the changes manually right here. But it is pretty clear that it's going to get very tedious to try to do this manually, and that's where Replicator really helps us, because what it allows us to do is it's going to allow me to group together all the lights, change all the parameters for the lighting, group together all the pallet jacks, change all the position, change their color, change their meshes, and even change the position of the robot's camera around in the scene, add all the objects in the scene, do all the randomizations together, generate the data in Kitty format so that I can directly feed it into my object detection training pipeline, and then I can train my model further there. So let me go back and show you what. So this is so towards the end of the blog right here, we've got our project which is being released publicly, and this is what we'll be walking through here in terms of how can you generate synthetic data with the pallet jack as our object of interest, and we'll be adding many more objects and randomizations into the scene. And the code which I'm going to be running right now is directly from here. So don't worry in terms of you being able to replicate something like this. It's straightforward to do. You can just clone this repository and you should be good to go. So let me actually just run the code first, and we can walk through what's happening there. Oh, I have the command right here towards the end. Yep, this makes my life simpler. Just going to copy paste this command, and I'm going to hit play. So what this is going to do right now is it's going to yep. We will walk through the script which is actually handling all the data generation, and I want to do it via the script because I'm changing many parameters in the scene, and I'm going to be using Isaac Sim APIs as well as Replicator APIs to load the scene, make various changes in it, generate the data how I want it to be, and then save it to the disk. So the script itself is very straightforward because we're going to use the core Replicator APIs directly, and that's how we're going to load all our assets into the scene. So this is just the pallet jack assets which we're using. We're just going to load them directly from the Nucleus server. And there are other assets called distractors, which we'll look at in more detail, but you don't need to worry about them right now. Let's directly go to our main right here, Python script. What's happening? We're going to load a stage. We're going to load the same warehouse environment which we had loaded earlier. And I'm going to add all my pallet jacks, and I'm going to add a couple of more objects into the scene called distractors. And distractors are really important. They're just general other USD assets in the scene which you can add. And what they do is they add more diversity to your data set. So a typical problem which you might initially encounter when you're using synthetic data is you generate data for pallet jacks, and I don't have any other assets in the scene maybe, and I don't even do any randomizations. What happens in that case is my model works very well in the synthetic domain, but the real world predictions are pretty bad. And that's something which we can see even in the blog. Let me bring up our blog right here. We have real world predictions. So this was the first iteration which we did, where we just added pallet jacks into the scene. We added randomizations for the color of the pallet jack, because obviously the mesh color right here can keep varying depending what sort of pallet jack you're looking at. We're changing the position of the pallet jack, and we're also varying the camera through which the data is being looked at. So basically your robot position. So this was the only randomization which I added. And that is how I generated my first data set. And then I wanted to see how well it's doing on the real world. So we have a publicly available data set called the loco data set, which has a few real world images of pallet jacks and objects in the warehouse. And that's what we leverage to actually show the model results. So you can see right here, there's a lot of false positives which have shown up on the real world images. So it does seem to get the pallet jacks if you look closely. Let me zoom in a little more. If you look in closely, it does pick up the real objects as well, but there are a lot of false positives associated with it. So we would want to reduce the number of false positives there. And that is where we figure out that we need to add more distractors, domain randomization into the scene to make sure the diversity of the data set improves. Coming back to a script, which is now generating data live here. So I've added a lot of objects into the warehouse, which are called distractors, like I described earlier with the pallet jack. And what's happening right now is the various domain randomizations going on. The position of all the distractors is consistently changing. Oh, let me make it full screen so it's easier to see. The position of the distractors, pallet jacks is consistently changing. The camera, which is looking at the scene, so basically the robot position, also keeps getting updated. And the lighting, the textures also change. And we've already got our data out. Let's go ahead and look at our data. I've saved it in a pallet jack data folder. And here it's just 100 images to get started. These are the sample images right here. So these are our images right here for the RGB spectrum. So these are just the color images which we would use for train. This is all the data which we've generated with Replicator, all domain randomization added. And this is what it looks like. And obviously, we would also need the annotations, because that's what's the cool part about Replicator. I don't need to worry about annotating data myself. I have it right here with me in the KT format. So this is a blank annotation file. We probably didn't have. This is right here. So this is the class of the object in that particular image. Let me open up the corresponding image. This is the image. We can see 1, 2, 3, 4, 5, at least 6, 7 pallet jacks right here. And also let me open up. So you can see 6 pallet jacks annotated right here, and the corresponding bounding box positions are highlighted in the KT format. So the other major advantage you get with Replicator is you can create your own writers. So I don't need to worry to make sure that the data is in a particular format. I get the ground truth out from the scene. And if I have my model requiring the annotated data to be in a certain format, I can make sure that I can write a custom writer accompanying my Replicator script, which will make sure that the annotations are in the right format. And that will allow me to actually train my model very seamlessly. I don't need to worry about making sure that there's a compatibility script in between to make sure that there's a transfer from the Replicator side of things to your own model training side. So we can look at what's happening in the script. I just create a camera. I set up Replicator to modify the pose of the camera. That's going to be randomized around the scene. I'm adding pallet jacks to the scene. I'm making sure that the color keeps varying across each iteration. I'm adding distractors to the scene to make sure that they're moving around in the scene as well while domain randomization happens. Changing light, changing material, textures. So a lot of randomization happening throughout the script. And towards the end, I just set up my writer. And that's it. I run the script and I can generate 5,000, 10,000, 20,000 images with the right annotations, and I can feed it into my training pipeline to actually see how well my model can do in the real world. And I can come back to the blog right here. Oops, sorry about that. Yeah, coming back to the blog right here, the other iterations which we proceeded with were basically adding textures and changing lighting to the scene. And we can start seeing that the model performance in the real world improves because the number of false positives in the detection start going down. And that is when we realized that domain randomization is actually helping your model to learn better from the synthetic domain and give you better performance in the real domain. And the last step which we did was adding more distractors to the scene. And that really helped increase the diversity of the data set further, because now your neural network understands what the object of focus is, and it understands what it should not be focusing on. And what it should not be focusing on is something the distractors really help with. And you can see that you can also add mirrors, you can add reflections and all that cool stuff, which you can leverage the powerful rendering mechanisms for OV. You can leverage all of that over here to make sure you can generate a very good data set. And the results from a final iteration were obviously the ones which were the best, where we added a lot of randomization, and we could see that the real world false positives went down and the true positives went up. And that was the best performance we got out from our model. So this is something which you can follow along yourself, and you can walk through this whole process. The GitHub is available right here. It's towards the bottom of the blog too, where you can walk through the whole workflow yourself. And I welcome you to try it out for different objects, given that we've got so many SimReady assets or some objects of your interest. You can set up Replicator, you can set up all your synthetic data generation pipelines, and you can then train your model and see how well it works in the real world. So you can run this in the cloud, or you can run this locally. That's totally up to you. And obviously, as a roboticist, the last thing which I would also want to do is deploy this on a real world robot. So it is pretty straightforward to do. We used a Tau model. It's basically just 4 code cells which you need to run, and Tau will train the model for you. Because we generated data in the Kitty format, you don't need to worry about any post-processing at all. I'm going to just pull Tau containers, and I'm going to make sure I can convert my data set to TF records. And for training, this is just the command I need to run. It's just a line. It's going to invoke the Tau Docker container, run your model with the data you've provided, and towards the end, then you can visualize what performance your model is giving on real world. And this model was trained entirely on synthetic data, and you can see that it started to learn well enough that the model can actually predict good results on the real world images, and that was something which we wanted to demonstrate. So I hope you found this interesting, and I would welcome you to try this out for your own assets of use, which you are probably leveraging maybe for AMRs or for different use cases. We certainly do have many USDs which you can leverage, and there are many importers as well which you can use on the other side if that's something of interest to you. And towards the end, I think there's one thing which I just wanted to cover is we had a new release for Isaac Sim, which was last week. So I'll just quickly walk through what's new over there. We've got a lot of new support for ROS. That's one major change which has happened with Isaac Sim, is you can now have your own OmniGraph nodes written with ROS2 at C++ level. Previously, it was only Python, but now we've enabled developers to actually write their own C++ OmniGraph nodes too. You can write custom message with Python, and you can have navigation running with RTX LiDAR, and that makes it really cool because now RTX LiDAR can pick up people asset detections in the real world. So when you're simulating people and robots together, RTX LiDAR is going to pick up those detections. So your navigation stack can understand people around for that robot in a better way, and that adds more semantics for a robot to actually make better decisions. We've got a bunch of new robots. In terms of sensors, there's an interesting thing which is happening there. You can now bring in real world sensors and simulate them with Isaac Sim. All your calibration parameters can now be fed into Isaac Sim, and that is pretty interesting if that is something you would like to look at. We've got advanced support for manipulation, for mimic joint supports, and certainly for Replicator, we've added more robotics use cases where added more randomization and simulation for mobile use cases and manipulator use cases. And there are a lot of other things also happening on the gym side of things for reinforcement learning with soft bodies and tensor APIs. So I would strongly recommend you take a look at Isaac Sim 2023 if you're interested in trying out these new features with updates to Replicator, ROS, and all the other good stuff. So Edma, were there any questions? If I missed anything, I know I went a little bit over, but sorry about that.
Yeah, Rishabh, I've got like a comment to make. I think what Jenny and you showed are two separate ways of using Replicator. You know, one where she's got a fixed camera use case, and things are going by in conveyor belt, but she's not using necessarily Isaac Sim as a platform. And you're using Isaac Sim and replicators built into it, essentially the API. So, for those of you on the call, that's why Replicator is so cool, because you can include it into your workflow like Isaac Sim, or you can just use it as is and build on top of it. So it makes it really flexible. I've got an outstanding answer I got to get back to on the, maybe Rishabh, you can answer this. I don't think there is. Was there any changes to the synthetic data writer in new version Replicator? I'm double checking with our PM team. For example, are there any new CAN writers for outputting popular formats such as Cocoa?
We are supporting Kitty and Cocoa, right?
Yeah.
I think, I'm already leveraging the Kitty annotator
Kitty
right
writer,
now.
yeah.
And
Okay.
Cocoa is also supported. So
Yeah.
you should certainly be able to use them directly. And like I said, one of the major features of Replicator writers as well is, if you are not using one of the popular writers, for example, which were Kitty and Cocoa, and you have annotations in a certain format, you can set it up yourself. You get the real world, so you get the actual object pose annotation information from Replicator, make sure that it's set in the corresponding format your model expected, and directly dump it to the disk, or maybe somewhere else if you're training it in that way. So that is very straightforward to do.
And if people have any follow-up questions, don't worry, the support does not stop at the end of the stream. You can go to the official support forum for Isaac. I posted a link in the chat earlier. You can go to our Discord to chat with other Isaac users, which I think is a very valuable resource. Other people using it. We have a channel specifically for Isaac Sim there. And I believe our colleagues, Eric and Jen, are going to be spinning up an office hour specifically revolved around Isaac Sim. So that will be really cool to watch too. So watch out for our calendar. I believe next week on this live stream, we're covering Action Graph for those interested in that. Rishabh, that was really awesome, really cool. And as evidenced by the people in the chat, people are very impressed, and they love to see more on this. So stay tuned on those future live streams. We'll cover more in the upcoming weeks. And I'm sure GTC sessions will also have some great information for people as well. Okay, I think this has been a fantastic hour. I want to say I noticed Pekka was here in the live stream. Pekka Barris is one of our Omniverse ambassadors from the community. And this came up last week, actually, on how people can actually leverage their experience or their interest in working with USD and or Omniverse into actually jobs. So there's a great platform that was formed by one of the Turbo Squid veterans called CG Hero. CG Hero just added Omniverse and USD and digital twins and a bunch of other tags that you can put for your profile. And what CG Hero is basically it's a matchmaking service. So companies, and there's some great large companies using it already today, can search for developers, creators with certain skills for their own projects. And also they also have a project management component to it. It doesn't cost anything for creators and developers to set up an account for yourself, like Pekka. Now he's actually getting job referrals from CG Hero, so it could be a great resource for people to check out. And of course, if you are really good in one or more areas of Omniverse, please be in touch with the Omniverse team. You can reach out to me anytime. There might be opportunities where we can introduce you to some of our partners who are looking for people with your skills. And as you could see from Jenny's great presentation, there are lots of great companies leveraging this technology to great effect. Speaking of which, do you guys, I know we went over because that was action-packed live stream. Do you have a few minutes to head over to the Discord and we could chat with anybody in the community who wants to, okay, cool. So let's do that. We're going to end the stream right now, and then we'll head over to Community Room 1 on the Omniverse Discord. We'll be there for a few minutes as long as people have questions. Big thanks to Amelia, Greer, Shira, Shreya, who just has been a big help in getting the materials ready for today's live stream. Of course, Nate and Akil also working a lot behind the streams for this one, and Heather, lots of people. Ashley, thank you for joining. Rishabh, thank you. And most of all, Jenny, thank you for taking I won't use your pseudonym anymore.
Yenster is very grateful to be here. Thanks for having me, and I'll see you guys in Discord.
All right, awesome. All right, thanks everybody. We'll see you on Discord in a few minutes.
Bye.
Bye.
Thank you. Bye-bye.